8 o'clock sharp, and I'm going to start right now. Okay? So what we are going to talk about is derived classes with resources today. Okay? That array thingy that I have written, good morning, that array thingy that I have written, and I ask you to please review it, the dynamic array thingy. Remember that? For your class, I think it was double, right? Double array. Why everybody's looking at me as I'm like nuts? We didn't do, we did an array thingy, right? And I actually, but the recording for this class for some reason didn't work out. The only class that recording was okay was the ZAA class. So I asked everybody to listen to that recording if you want to review it. Make sure you go through that when we are getting to templates. That is probably the time you are coming in. For quizzes, because no other class is doing online quizzes, I'm not going to do it online. It's unfair to the other classes. So it's the quizzes. I sent you the post on the Teams. You know exactly what the schedule is and which quiz is done when. It's with the date and everything. I put it in there so you know exactly when it's going to be. She's looking angry, so probably. So yeah. And also, give me a second. So we are talking about with derived classes with a resource. So to give you an example of, like, you know that I code when I teach. So I want to give you a very simple example that I can go through everything very quickly. So I start with a class called name. So let's say we want to encapsulate a name. To encapsulate a name, before we start, sorry, any questions about anything down to this point? I forgot to ask. Ooh. On Teams or after the class, if you want. Yeah. But you have questions like that, you don't have to talk to me on Teams. The only thing that I like to talk to you on Teams is when you are asking about coding problems. Because then I can open your GitHub and I can fix your code and you will see the history of what I have done to correct your coding. If you want to talk to me about something after each class, I'm yours. I'm not going to run away. We can stay here for an hour if you want. We can talk, okay? But coding, I like it to be on Teams and online so I can open up your repository, modify your code over there, commit so you can diff it and see what I did, okay? And reflect about it, okay? So helping with your code on Teams, everything else, I'm all yours after the class, okay? Any other question?
What's the benefits of using O stream or I stream instead of like
just using cout in there?
Yeah.
Okay, so it's actually a beautiful question, okay? Question is that what is the benefit of passing iStream and OStream through the I/O input-output functions inside the class? Why not just use cin and cout in there without passing anything? Anybody knows the answer to that? So, correct answer, you know why, but you didn't explain it properly. You're not a teacher. We didn't expect that. Anyone else have any? Okay. If iStream was only cin and OStream was only cout, you were right. Why? Because cin and cout, they're all global objects, right? We can just use them. But it's not only cin. Sometimes I want iStream to be a file. Sometimes I want iStream to be a string. So sometimes I want iStream to be whatever, a port on a computer that I'm receiving networking from. Because of inheritance, you need to pass the mother of all input classes to the function, so when you pass the child, it can change to the child. so it becomes updatable. If you don't use that and only use cin, then your function is doomed to only receive everything from the input and nowhere else. Does that make sense? Yeah. So that's why I always say this is like a standard way of doing it, and we defaulted to cin. So we go iStream reference, and we default it to stdcin because we know usually people want to use cin. So if they don't mention anything, by default, it is cin. But if they want to change, they have a choice to do so. Did I answer the question? All right. She has one of those faces that I cannot read. That's why I have to, because students, when I usually answer the questions, I can get from their face if I actually can, but she's focused, and I'm like, did you get what I said? Or you did not? Okay, so, all right. Are we okay? Any other question? Good questions coming up in this class. You are much better than the other classes when it comes to questions, I have to tell you that. Okay, yes. Yes. I lied. It's actually 2. The third one, yeah. So we say 3 ways to initialize. I'll explain it over here. Okay, so there are 3 ways to initialize. One of them is like we tell it's initialization, but it's not really initialization. So the first initialization, so let's do the name. So I want to design a name, and I'm going to answer your question. So it's going to be like killing 2 birds with 1 stone. Such an awful expression, but hey. Okay. I don't know. All right. Let's see. Hitting 2 targets with 1 arrow. All right. So if I have, sorry, I have to hide behind the podium what I'm doing. It's anyways. So a name has some value, right? So I don't know, Fred, Jack, Jane, I don't know. Why all the things that I say start with J, except from the Fred thingy. Anyway, so any name it could be, right? And so the reason that I put name over there for default was that the structure is sound, and I can the constructor is not supposed to be defaulted. I'll fix that. But the reason I did that is that when I make my structure of the classes that I want, I write constructor default, so everything falls in place. I can actually compile it and see if everything's designed properly. Then I'm going to switch everything. So that's how I do it. If you see, I have a full name over there that is the same way. But anyways, so the very first way that we are doing the initialization is when we are initializing here. Okay, when you initialize the variables inside the attributes inside the class, that's, I don't know if I can put this term for it. It's a global initialization. It means no matter how the object gets created, that's how it's initialized. Are we good with that? Okay. Another way of initialization is to do it here. So when I'm actually having a constructor created, let's say I have a default constructor, and I want the default constructor to get created. So let's have the name over here and split the window. Another way of doing the initialization is to do it in the constructor. So when I create the constructor, in here I'm saying when you create that, make the m value to be new character something like I'm going to put over here 1. Okay. So I don't know. In here, I am saying initialize m value with a dynamic array of 1 element. And I'm going to make it null. So I can actually make it null so it becomes null. So something like that. Okay. But after doing this, if I want to set the value of that character 1 to something in here, I can do this now. I can say m value 0 is No. So line 6 is initialization. Line 4 in name.cpp is initialization. But line 5 is not. But we call it initialization. I'm saying I'm initializing the value here. But at line 5, the object is built. All the properties of object are created. Now I'm setting them to initial values. So it's not true initialization. Okay? Now I can explain. Like if I had an object over here inside the name, if I had a real object with constructor, destructor, and all this stuff, and if I do not initialize them on line 6 or line 4 of name.cpp, and I set them to something at line 5 in the name, you will see that the default constructor of that attribute will be called before the constructor is actually executed. So it is initialized, but you are setting it to something. So we say we initialize a class in its constructor. That's true for bigger picture. When you get out of the class and you look at the class from afar, not from, you don't scrutinize it. You don't get close and see what's the mechanism behind it. When you get out of the class, look at the class from outside, you are initializing a class in its constructor, because when the class becomes available in your code, its constructor is called, right? So from outsider's point of view, inside the constructor, you are initializing the class. But when you go inside the class and put it under microscope, you will see that all the attributes of the class are initialized before the constructor begins. So those type of parts of the class are initialized before the constructor begins, either inline or at the initialization area. Was that good for you? Yeah. All right. Yes. If this is dynamic memory allocation, it is necessary so I don't have garbage in it. But it was just an example of the sequence of the things that happen. I'm going to wipe it. I'm not going to do it this way here. It was just an example to show what are the 3 stages of initialization that I was talking about. To what? To Tom? Yeah. Then you would, yeah, you would, I would do it completely in the constructor. Why do I initialize it? There's no need. Because it's a pointer, right? I make it null over there just to make sure it's null. Then inside 5, I don't want to write your code as less cryptic as possible. So if someone else other than you looks at your code, that someone else is usually you 2 months after you wrote the code. Okay? So when you look at your code, you don't have to say, what the heck did I do here? Don't do that. Try to make it as simple as possible. So that pointer character and value over there is a primitive value, right? I don't have anything over there to do anything with it. But if I had an employee had a class name inside, then you have to think about it differently. I would do what you're saying if I want to set it, or maybe wanted to set it to no name. If I wanted to do that, then I would actually do this here. Character, no space, NAME. It's 8 characters total with null, I think. We'll see. So I will find out. So 8, then I'm going to say, I have utils over there, right? So ut.str copy into mValue, no name. Something like that. Right? Because when they are using the name in a function, when they create the name, they don't see these things happen. When they have the name in the main program, the constructor is called and it's initialized. Okay? I'll give you more example when I actually finish this thing. Yes. Pardon me? Oh. You did not review the animal thingies. This comes from the animal thingy that I did. Remember, I said I created the utilities class with all the good stuff in it, and I created an external thing called UT that you can use it that I can use it everywhere. So UT is my utilities object. It's like you have a C out to print. I have a UT to have the utility functions, and these are all the functions that I have written over time that I may use in here. Many of them I may not use, but I don't like to include standard C string. That's my utility. That's my toolbox. I'm a plumber. That's my toolbox. I'll take it around with me. Oh, of course you can. Any code that I have, you can copy. Take it. Yeah, I would appreciate it if you write something over there, say the utilities class is farnets. I have no problem with that. But if you don't, you're not cheating, because I'm your prof. You're supposed to use my code, right? All right. So you can use my UT, and you can even make it better and let me know, and I'm going to incorporate your code, and I'm going to add it in a comment that this is the person who did it. Okay. I'm going to add a few stuff to it today. Hopefully, I'm going to finish this week. And all right. All right. So let's go back to the name. So now I'm going to go out of the thing that I wanted to say, and I want to create a name. So out of all the questions, and I'm going to design my class based on my encapsulation. So I have the name, and the name that I have, I want to set it to something. So what in here is that I'm going to pass a constant character pointer value in here. And this value of mine is defaulted to no name. Okay, so in here I'm going to have a constant character pointer value, and now in here I'm going to say m value is equal to new character ut dot. Why didn't it answer the thing? It should do it. What did I do? Oh, yeah, thank you. Okay. So ut dot, it still didn't do it, but it doesn't matter. strlen of value plus 1. And then in here, I'm going to say ut.str copy into value the value that I have. So I am creating a constructor for my name to set up. And you'll see soon I'm going to take all those things away. So, and I'm going to make it better. So you see that. Let me continue, and we'll see what happens. So I think we're good. So I want to see if everything's okay over here. I'm getting the green thingy over here. I want to see if it works or not, or I'm making a mistake. So what I will do over here, I'm going to come over here on my name.cpp, and I'm going to just compile it. So what that thing does, it compiles only my code, only my name as is, to see if I made any mistake, and I see that I don't have any mistakes. So IntelliSense is doing something over there that thinks that I didn't do it right. So don't always trust IntelliSense. Sometimes it makes a boo-boo, okay? It says the definition is not found, but the definition is there. Or maybe I'm making a mistake. I don't know. We'll see. We're okay down to this point? All right? So now, obviously, as soon as I do this, I'm going to create a destructor. So I'm going to go name, rule of 3 immediately for it. And in here, I will create the name's definition, the destructor definition, and that's a delete name value. Are we okay with this? All right? Anything wrong with this code? Yes, thank you. The destructors are always virtual. Okay? Virtual. That was presence of mind. For that, I'll give you 1% for the final test. So if you get a 49, it's a pass. All right? These bonus marks that I give you, remember it. I'll remember it when you remind me. For that, I got 1% on that topic, and I'll give it to you, okay? But 1%. It's a small little token of appreciation. Let's put it that way. All right. So now that I have this thing, I want to be able to show this thing on a screen or something. Then I'll do the output thingy. By the way, let's do the rule of 3 and be done with it. Because it's a class with resource, right? I need to have rule of 3 for it. So to have rule of 3, I need 2 functions created. Name the first one. Which one is it? Copy constructor. So name const, name reference, and that's the copy constructor. And then copy assignment, obviously. So that's a name reference operator assignment that receives const name reference n, right? So that's that one. The very first thing you do, you create the copy constructor. And how do you do that? You say operator assignment n. Done. Your copy constructor is done. Got it? So because they are essentially the same thing, what is the difference between copy constructor and copy assignment? No, they both do deep copy. There's one difference. Thank you. You got 2% for that. Okay. All right. So the difference between a copy constructor and a copy assignment is that a copy constructor creates objects, copy assignment sets objects. Difference between initialization and setting, right? Right? We are okay down to this point? So we have to create our copy assignment only in a way that it doesn't, when it's called in a brand new object, it's not going to crash. That's the only consideration. Other than that, so when you are doing rule of 3, if rule of 3 each one has a mark, the only thing you didn't get mark over here is the copy assignment. This is how you answer it in a test. And then you think about copy assignment. Short, correct answers are always preferred. Don't implement every single one of them. So if you don't implement copy assignment, you only lose the mark for copy assignment, right? N in parentheses, which line? N is an object, isn't it? So I'm calling the operator assignment, the assignment operator as a function. You will see. They do it like this too. They do it like this too. Do it whichever you like. Line number 9 is potato. Line number 10 is potato. Your choice. It doesn't make any difference. They're identical. You are calling the copy assignment. Okay, so let's do the copy assignment. So stages of creation of copy assignment. Number 1, make sure you're not copying it to yourself. You're not self-assigning. So number 1, no self-assignment, which means if this is not equal to the address of n, the copying happens. And then at the end, you always return the current reference. That's step 1, universal. Okay? First, you make sure you're not doing copy assignment. If copy assignment is happening, you just return this and you're done. If somebody says, assign me to myself, you don't need to do anything. It's already assigned, right? That's what it's going to do. Número dos. Okay. Number 2, make sure that the target doesn't have any memory assigned to, which means wipe out the memory of that one. So delete m value. You are being assigned to something, right? You are assigning yourself to a value that is coming. So first wipe yourself out and get it done. So that deletes it. Will that cause any trouble? So line number 13, will that cause any trouble in a constructor, copy constructor? No, because copy constructor is essentially creating a new object out of another object, right? So definitely there are two different objects. Therefore, line number 13 is okay. Line number 14, delete m value. So I am just creating an object. If I delete the m value, will it crash? The answer is yes, because m value doesn't have anything in it. But I was wise enough at line 6 of my name.header file to have an inline initialization to null, which means before anything happens, my m value will always be null. Therefore, line number 14 has no effect, will not do anything to a null value. So that is fine too. That's why I always suggest to initialize your values in line. That guarantees that you have clean attributes in any constructor. Copy, regular, default, whatever. Okay? Line 15? It's not that it's not necessary. It has no effect when it's called in a copy constructor. In regular things, yes. If my name is Jack and I want to make it Joe, it's going to wipe out Jack and then set it to Joe. But if I'm creating a new object out of me, then there is no name over there to be wiped out. So that no name being null, it means my operator can be, because of line number 6 in a header file that makes the m value null, my operator equal is reusable in a copy constructor. Okay?
Has all the value. Then we want to.
One more. Sorry, I was thinking about. I confess that I was just thinking about a function and you said that I didn't listen to a word that you were saying. One more time.
What if value?
Yeah, it will be deleted.
Do
Which line?
14.
Okay.
You said as value.
When it's created, that's past. When you have two existing objects, everything's created and done. So you have two objects. Again, you have a Jack, you want to set it to Joe. So Jack has already been created. It was null, then it was set to Jack. Life is beautiful, the name is Jack. Now I want to set Jack to Joe. So I have to wipe the Jack out before I make it Joe.
Yeah, because my question is why did you say that it's not necessary?
I didn't say it's not necessary. I said delete will not cause trouble when operator equal is called in a copy constructor to create a brand new one. If I did not have this one, this would have crashed. Why? Oh, what the devil is that? What is that? Okay. What the? Can anybody tell me what is that? Okay, I'm scared now. And it's actually recording. Is it recording? Yes, it's recording. Did I click? Oh, shoot. So I was recording that area. Apparently this plus and minus do something in here. I clicked on it by mistake. But anyway, was it there for a long time or it just appeared? Okay, good. So just wanted to make sure I'm not good. So now I know I can actually focus and only record some parts. That's interesting. I didn't know that. Good. All right. I've used this for years and I don't never use that feature. Anyways, so what I was saying is that if I do it like this now, when copy constructor is using operator equal, let's walk through it. Okay? So that's a copy constructor, which means an object is being created out of another object. Okay? Therefore, as the object is being created, the copy constructor is being called, everything becomes available. Value doesn't have any initialization, so it has garbage in it. It has some random number in it. Then it comes to operator equal, and operator equal says, am I the same object? It says no. It comes in here, it says delete m value. M value has a number in it. So it thinks it's memory that's supposed to be deleted, and poof, it crashes. So having that thing null, make this line ineffective when it's called in a copy constructor. But everywhere else, it will do its job. This lecture could have been 15 minutes. I don't want to do that. I want everything to get crystal clear when I get to it, okay? So sorry if I'm going baby steps, okay? If I don't finish, we'll continue in a lab time. So don't worry about it, okay? For those people who already know these things, be patient, please. We are working as a collective, okay? All right, so now that I have done this, I have to say m value. I deleted m value is equal to, oh, wait a minute, I have the code already. So it's exactly this, correct? The difference is that this is n dot m value, right? And this is n dot m value. I hope everybody appreciates what I just did. When you do something like this, that craves to be a function. Okay? Remember that. And as we go through, when I do keep doing this, then we'll see what happens. Are we okay? Any question, any problem over here down to this point? Any problem? You want to ask me? Are we good? Are you okay? All right. Are you okay? All right. All right, so that's that. So now I have the rule of 3 set. So this thing will work in any case that I have. We'll test it. Let's set it and print it and see how all those good stuff are going to work, okay? All right? Do I have anything to read a thing from in this UT thingy? Do I have get int? Oh, I have a read that receives a C string up to maximum size. And the limiter is new line. I do not have anything else in here, so probably I need to write something for it. Anyways, well, we'll see. All right, so I want to read this from console and write it into console. Do I need any yeah? So let's first just write it on console and test it, okay? So in here again, OStream, std, OStream, reference, write, and I'm going to have std, OStream. So in here I'm going to write include IOStream. Why don't I can just, I keep repeating std over here. Can I write over here using namespace std and just remove these things from here and get over with it?
And you can, but it's bad design.
Thank you. Thank you. Another 1% is happening over there. Okay? So it's bad design. Why is it bad design? Can anybody tell me? No, maybe I have 900 over there. No. That's a very professional way. Somebody has an easier way of explaining that. You're absolutely right. I'm not going to give you another percent because you already got one. You only get it once a day. It doesn't mean that you didn't. Actually, it's good. It's better because one person keeps answering, then the class becomes me and him. So another person telling? Okay, if you write a using statement in a header file, any code that includes that header file will start using that namespace without knowing it. Right? And that's not a good thing. Maybe I don't want to use that header file. Maybe I am using another thing that has lots of conflict with that header file. I want to use another namespace. So that's why in header files, you never use namespaces. You always hard code it. You write qualifying stuff, because if you do it, again, all this is review. You're supposed to know all these things. So in here, I'm going to say reference OSTR is set to std cout. So I set all the good stuff that I have in here to make my function right. And immediately, I'm going to write over here the helper function to use it. So std ostream reference operator insertion operator. And the insertion operator of mine will receive an std std ostream reference left operand, and it receives a constant name reference and right operand, right? Are we okay with this? Let me just slide it. At the end of the class, can you see this? Or you want it bigger? Is it good? Can you see this? Can everybody see this? Okay. Because I want more real estate, so that's why I'm doing it. So, and that reminds me that this has to be constant, because it's just, yeah. Okay, so that's my operator thingy. So first of all, I'm going to write that because it's an easy one. So in here, I'm just going to say return right operand dot right, and I'm going to pass the left operand to it. We okay with this? Are we okay with this? All right. Now I can think about writing. So what do? Is there any circumstance that this object will be in a safe empty state? We didn't design it that way. We could, let's do it that way. I'm not going to put no name over there. I'm going to just make it blank. So in here, I'm going to say by default, it will be null PTR. Okay, and now what I need to do in here is to actually check and see if everything is null or not. So in here, if the value that is coming in is null, then I have to actually, that makes it too complicated. It's not carried away. I want to teach derived classes with resources. That makes it too many ifs and stuff. Let's not do that, and we'll continue. So we have no case that is going to be in a safe empty state, and I can, so the m value, although it's defaulted to null over there, but in no constructor, it will be left as null. Okay? The only problem that I have, the only problem that I have is if somebody passes null to the value over there for me. You see that? So we have to fix that. So if somebody by mistake passes a null, so if they don't pass anything, it's got to be no name, right? But if they pass null over here, then I'll be in trouble, correct? So maybe I want to do something like if value, then do something like this, and otherwise to enforce that thing all over the place. You see how awful I'm writing the code? I'm just making it work, and I'm going to make it better later. So, got it? What I did? Again, craves for a function. I keep repeating code. You see that? If I see that, such a thing in your assignments, you will see that you will receive a note from me saying that these things could be done in a function because you are repeating it. We're going to replace it soon. Are we good down to this point? All right. All right. So I have no case of that. That's why this can be very simplified. I can simply say OSDR, return, OSDR, and M value. Because it's impossible for M value to become anything, be not printable in here. You follow? My M value will have something in it, either no name or something. Are we okay with this? Everybody's okay with that? Now I can actually test it, see if it works or not. So I'm going to come over here in main, which I did not create. Whoa, what did I do? Cancel, cancel. Add, new item, C++ file. So in here I'm going to say name unit test. So I'll include name.h. I always include the library stuff first, using namespace std, using namespace stds, int main, return 0, return 0, and so in here I'm going to say name set constant character I'm going to call it create name constant character pointer value, and in here I'm going to say name n value and return it. Okay, now in here I'm going to say name the name, and in here I'm going to say cout the name, and then I'm going to say the name is set to create name, and in here I'm going to say Fred, and I'm going to say cout the name again. So I'm testing everything here to make sure all the stuff are working. Why? Because create name creates a local variable name. So that's the place that regular name is created. In 12, default one is created with no name. When at line 14 I say create name Fred, the Fred is created, then passed by value, therefore copy constructor is called. That copy constructor creates a nameless object. Then the nameless object is passed to the assignment operator, setting the name, and the name is printed. So everything is tested in this little code. Okay? So we'll do an F10, and hopefully it's going to crash. Let's see what happens. So I'm going to go step by step. You always wish your program to have some trouble and crash, because usually when everything is okay, you should go immediately go buy a loader ticket, because it doesn't happen, right? If some hidden bugs are the worst ones, the one that happens 3 years after you actually release your software. Those are the ones that are really bothersome. But anyway, so we're going to come over here and start. So it creates the name, and in here, as you see, the value becomes null. That's the very first thing. Then it comes over here, and value is now no name. So strlen will be no name, and it actually creates the value. It comes out. So cout will happen, and no name is printed. Pardon me? One more time? Yes. I didn't do the null thing yet. I didn't test that one, actually. So you are saying this. So it actually doesn't test everything. So now I'll do it like this. So I'm going to say over here, I'm going to make it even better. So in here, I'm going to make n. And in here, I'm going to say null PTR. Okay. And I'm going to say n is set to value. Now it's going to really be crazy. Now everything is set. Okay. Yeah. You will see that like crazy stuff are going to happen at line 8. Okay. So let's stop it and then redo it again. So because I just want to make sure everything works. So now the name is created using the default value of no name. So value is not null. So that happens over here and it is printed. Now it says create name Fred. It comes over here, value is Fred. Now we are creating a name with a null pointer. So it comes in here. It's not set to value anymore, but it's null. So it comes over here, does no name anyway. Got it? Now it comes in here. It says set value to name. Okay? So set n to a Fred value. There is no assignment operator overloaded for that, correct? So what does it do? It says at right side, I have a constant character pointer. At left side, I have a name. What can I do? Can I make that constant character pointer turn it to a temporary nameless name? How can I do that? I need a constructor for it. Do I have a constructor that accepts a constant character pointer? Yes. So the right one will be casted to a nameless constant character pointer. So as you see over here, it happens. It comes in here. And this is the nameless being created with value Fred. So the nameless one is created now. And now the assignment operator is called for that nameless. Going in here, so it's actually copying that nameless. They are not the same. It's going to delete the value of no name. Then it's going to set it to Fred, return it, and as soon as it does it, that nameless is not needed anymore. Therefore, it goes to the destructor, deletes the nameless one, and comes back over here. Now it wants to turn the name, return the name by value. That's a copy constructor. So goes to a copy constructor, copies that one. It didn't do the copy. I'll explain later on why, but no worries. This is compiler trying to make things efficient. Okay? No name objects never get destroyed, never get copied. Okay? When you saw, I'll come through it later again, and you'll see what happens. But anyways, so it comes in here. It is being assigned, and so the value is deleted, which means no name is deleted. This is the main one. This is the name. And everything is set, comes back over here. Now it goes to the destructor and deletes the original one that is returned from the function, and that is deleted. It comes back in here, prints Fred, and comes out. So that, and if I just was careful enough not to write such an awful code, I wouldn't have these many things. Like somebody writes something like this, they don't see what's happening behind the scene. So it looks like it's a very simple, like 5 lines of code, but because so many things happen behind the scene, it's an extremely inefficient thing. But we wanted to test this to make sure everything works. So hopefully now we are at the end. It is done and done. So we are good. Are we okay? Run this on Valgrind later on, see if it works. Yes? Line number? Line number?
Value 2.
Yes.
How do we pass an object?
So it becomes assignment, copy assignment. First, a temporary nameless object was created out of value. So at right side of that assignment operator at 8, you will have a nameless object of type name created. Then that nameless object was set. Yes?
Pass by value.
The constructor. But so wait. Let me just explain to you. Compiler tries to make things efficient all the time. When it's 100% sure that what you are doing is redundant, it recreates stuff. Let me just explain something to you. So I'm going to walk through and show you something in here. You will see what happens. So let's come right down to the part that I'm... Oh, sorry. I didn't want to do that. Let's say I come right to the name over here, right? Take a look at the sequence of execution. Okay, so this happens. Okay, so it creates the name out of that null thingy, right? Creates the no name, right? Now take a look, see where the execution jumps to. What happened? It didn't go to line 8, it jumped to line 9. It's executing the return statement. Why? Because it looks at your nonsense and says, what the heck you're doing over there? So this code could have been this. Right? Create a temporary nameless and return it. So the compiler does that for you. It says, you're nuts. I'm not going to do that. I'll do this instead. So yeah, but if the object is up, let me tell you something. There is an important rule that have existed in compiler efficiency since I remember, which is a nameless object never gets copied. So if I do that, the copy constructor will not be called. The compiler says, it's already nameless. Why do I need to copy it? I'm just going to rename it to something else and reuse it. So if you pass a nameless object by value, compiler simply assumes its value and it will not recreate it because it's nuts. It says it's already nameless. It's already supposed to die. Why should I kill it and create a new one? I'm just going to reuse it. I recycle it. Let's put it that way. So compiler recycles nameless objects. It doesn't kill them. And that's what happens. But what is important, although we are trying to understand how things are running in here, and walkthroughs like this are never accurate because you don't know how the compiler is doing efficiency. I can run this in 3 different compilers from 3 different eras, and you'll see 3 different outputs comes out. That's why we have rule of 3. No matter what, we are covered. You follow? I used to be able to just write it and say, tell me what's the output, because the compilers were not that efficient. They would do what you asked them to do. Now they're trying to make your code efficient. Because of that, when you write crazy code that is 100% sure that could have been written easier, they actually make it better for you behind the scene without you knowing. Okay? So rule of 3 to guarantee everything is good. Are we okay? Yes. Pardon me? Why can't I understand what you're saying? One more time?
So by nameless objects,
No, temporary. See, line 7, what happens over there? What am I doing? I'm saying name value. Name is a constructor. I cannot call a constructor. So what happens over there, it actually, so if I do this, what does it mean? What line 7 means? It means create an object of type name and call it n. Create an object of type name and call it n. Is that clear? We're good with that, right? And then when I return it, what needs the compiler to do? What does the compiler need to do? It needs to copy that and return a nameless object from scope of function create name to scope of main, and then kill it. And the compiler says, why? Why did you even name that n? You don't need it. It's going to die. I'm not going to do that. So what the compiler will do, some compilers will do, is this. So when you actually write something like this, you're actually asking the compiler not to give the object a name. Create a name in cyberspace, that doesn't have any name. When I say name, it doesn't have any variable name. So the object name gets created, but it doesn't have a handle. It doesn't have name. It doesn't have NASW. It doesn't have anything. And simply wants to copy that. But by golden rule, nameless objects are recycled. They don't get copied. Therefore, it's going to directly get returned out. Does that make sense? Okay.
Return reference to.
If you do a reference to the object, they will ignore it. Again, it says, you're nuts. You want to return reference to a nameless? I'm not going to make that. I'm just going to make it a regular one. Right? Okay. I don't know if it's going to work or not, but I suspect that's going to be the case. And now it's actually giving me an error. Initial value reference non-constant must be a null value. Yeah. So it doesn't even accept it. Okay? But I don't know if I'm mistaken or not, but I remember long time ago I did that and it actually compiled. But it just ignored it and made it I don't remember. But now you cannot return the reference of a local variable. And that's a local variable. It's going to die. It's a nameless thing. It's going to die. You cannot return a reference to it. Because the outside is going to receive reference of something that doesn't exist, right? Doesn't make sense. All right. Are we okay? So let's keep it short. We tested our object and it works, okay? If you wanted everything to actually work, like actually test it properly and see everything's okay, you should have done something like this. So say n over here null ptr. Then in here you have to say something like n is set to value. Then you're going to say see out the n is n, and then return n. So you're actually using that thing. I don't know if compiler actually is going to be able to actually make it. It cannot say I'm not going to name it anything because you're actually doing something with the object in there. So the object needs to be available to be passed to other functions and stuff like that. I really don't know. We can walk through it and see if it works or not. But again, these days you really don't know. I mean, again, you just do this to make sure you just do the rule of three. So now in here, it goes in here, creates that null thingy. So that's good. Now it, again, it's actually making it. See, it's actually doing it. Still, even when I'm printing it, is actually going to return statement first. So anyways, I thought maybe if I do something, it cannot make the code efficient, but it's actually doing it. Anyways.
So this makes the debugging so hard.
Yeah, that's why you have rule of three. It doesn't make debugging hard. It tells you exactly what happens.
Like if I can go through line by line and see where the problems are occurring, then
My dear one, we didn't have this. You had to write print statements in it to see how to debug. Or if you were like very good, you used GNU debugger. And it would print every single value coming out. You had to browse through logs of execution to see what it is. So it doesn't make it hard. It's actually beautiful. Okay? Enjoy it while you can. All right? Because there comes a time that you don't have something that you can actually debug. You will see when you get a job somewhere. This is some of them you can, some of them you can't. But anyways, so I think now it's actually doing this. Nah, forget it. So we are fine. I'm just going to put it back. I'm going to leave it as is over here. So we know everything works. Overall, when I run it, okay, it runs. And it works perfectly because I have rule of 3. Okay? Because I have rule of 3. Run it in Valgrind and you can see that. Okay, so that's that. Now that we have done this, what's the time? 9:03. I think I fried your brains enough. Let's go for like 5-10 minutes break. Please, 5-10 minutes, not 15. Okay, if anybody wants coffee, I have a bucket over here. Anyways, be back in 5-10 minutes, please. Thank you. And remind me to unpause, because that's... All right, now that we have the name, actually, that is a thing, so... Okay, so... And I'm going to add another unit test. So what I thought of would be a good example to actually explain is to apply inheritance to full name. Saying a full name is a name with a last name. Right? So a full name is a name with last name. So I said, I'm going to design it that way so we have inheritance. And in both of them, we have resources. So we can actually see how derived classes with resources work. So in here, my full name has a value too, but this full name has a last name in it. So a character pointer last name, or let's call it surname, last name. Okay? So now that it has last name, I have to do all the stuff that I'm doing for both classes. Now, for us, am I recording? Yeah. I was just, did I? So the whole point of derived classes with resources is to tell you that, remember, when you are creating classes with resources, rule of 3, you must always think of what happens to my parent, because the parent has resources too, and you have to take care of it. We already learned how we can invoke constructors of parent class in the constructor of the child in inheritance. Okay? All you need to do is to just remember to do so. So we're going to do the same thing in here. So again, I have over here the full name that I'm going to put const character pointer value for that. And this one I'm going to put no last name. Okay? I'm going to set it to that. Very similar. We just want to see how things work. And I'm going to make sure that this value over here is actually set properly. It's null. Then I'm going to do the rule of 3 and then see how I can actually apply it. So I'm going to write the signatures for it one by one. So I will have full name that it's a copy constructor. So I get a constant full name. Oh, and full name, sorry, receives a name too. So let's call this last. And over here, I'm going to have const character pointer first. Come on. First equals to no first name. Okay. So full name reference, and then it's going to be full name. Oh, full name, it doesn't have that. Okay. And then I have full name, reference, operator assignment, and I have over here const, again, full name reference fn. I have the destructor, full name, like that. That is virtual. And another thing that we forgot in the name, because I am to implement the full name properly, I want the right to be updatable. So I'll make it virtual. So when I have a full name is a name and it has a right, so I can actually go one by one. We okay with that? All right. So now I'll save it. And then in name, I'm going to create the right. So in here, I'm going to have, I don't need to write virtual, but somebody wants to probably get something out of full name. I don't know, call it a title, and then create full name out of title and add a Mr. and Mrs. at the beginning. Because of that, if they don't see the name, if they don't see the source code of name, I want them to know that right is virtual. Okay? Or yeah, it's just right over here, full name. So full name, or we can actually return a name in here. We don't need to return a full name. So I'm going to say name, and I'm going to say right, because it has to be exact. Oh, sorry, OStream. What am I talking about? OStream reference, right, and in here, OStream std, OStream, and I'm going to set this one in here as include IOStream. So I'm going to get the exact same thing that I have over here and put it right over there. Not to make any mistake. Virtual is a new version of virtual. Okay, so that's that. Okay, so it does the exact same thing like the other one. I didn't do the iStream for it, but please do it later on. Yes. That's wrong. That's very wrong. Each header file has its own safeguard. Let's not do it. And it has to always come before. So I make that mistake a lot, even if you see it in my workshops. Yeah, that's wrong. It's not supposed to. Usually it doesn't cause any trouble, but it's better to always do that. OOP244. Yes.
So line 4 and 5 go.
Yeah, because they have their own safeguards. Or you can bring it in. That doesn't make any difference. The important one is that the sequence is done properly. Sure. If it makes you happy, do it this way. No problem. But don't. I mean, like, yeah, you can do it this way. There's no. Yes. That's called backwards compatibility. You want your code to run with a compiler from year 99. Those, they don't know what is that one doesn't know what is pragma. So anything that you find out that is recent, if you want your code to be backwards compatible, do it. And because you're going to later on learn how to write conditional programming. Like, for example, you're going to write a code that automatically switches code between platforms. Let's say you are writing a code that does some screenwriting on Windows, and you want it to work on Mac too. And they're completely two different things. The functions are similar, but they are different. So you write one function using conditional expression. You say, if the check the operating system. If it's Mac, compile this code. If it's Windows, compile this code. If it's Linux, compile this code. You want to, so we are doing this so you are ready for that. Baby steps, yes.
So why, like, why do you put it? How does putting it above like better? Because it do defensive pick, and if it fails, we have to pick the
They all have it. The thing is that it does not make any difference. They all have safeguards. If IOStream is already defined, it's not going to get.
But you're still like.
No, I'm just talking about it's better. It is imperative to have the library ones included first. And I cannot explain why. Oh, damn it. Okay. Let's say you explain. Let's say you, in your program, define something called NULL, null. Isn't that already defined as standard input output? Are you using standard input output here? No. How do you know it's not included in IOStream? No. Yeah, standard input output. How do you know it's not included in IOStream? Maybe it is. So you don't know. So when you are, if you define NULL to do something for whatever, you already have it defined, right? So there are conditional expressions that write if this is defined, undefine it and define it to the new one. If you put yours before standard input output, you're breaking standard input output. Because the definition of null for standard input output will go bananas. So please don't, trust me on that. Put all the library stuff before, so if you are screwing something up, your code will carry the error. Many times happen that students come to me and says, my standard input output is giving me an error. And I'm like, it's not that. You included something before standard input output that is causing a standard input output's null to be redefined. And that screws everything up. So always put that one so you get the error message in your code, not the system's code. Okay? OOP244. Anyway, so that's all we had, right? Did we have anything else in there? And I don't need to. Huh? I don't need to. It works for both virtuals, right? It has for this one. Okay. So first, the constructor. Let's create it. So for the constructor, all I need to do over here is to pass the first name to the constructor of the name, right? That builds it. Are we good? Everybody's okay with that? All right. And the next is, the code is identical. I'm going to say if last, and then I'm going to say, and I'm going to do, and I don't want to write all those things again and again and again and again. So I'm going to just get the code over here. I don't want to. I hate repeating stuff that are not necessary. So I'm just going to get this thing over here, copy. And I'm going to come over here and say void reallocate reallo copy. So it reallocates and copies, okay? And in here I'm going to have a character pointer reference PTR, so destination, and a constant character pointer source. Okay? So now in here, I'm going to bring my code. Okay? So I'm going to delete the destination. I have it a reference to make sure that the pointer that is coming in is a new name for the pointer that is coming from outside. Because if I don't have that reference, I delete something over here. It's not going to, and I'll tell you. So in here, if I say actually destination is something, it's not going to affect the other one. So that's why I'm doing this. So in here it's going to be source. And in here it's going to be destination. And in here it's going to be source. Right? So it's going to reallocate and copy. When I say reallocate, why did I put re over there? Not to have the mistake that we had, because reallocate means I'm going to delete it first. If I say allocate and copy, it doesn't need those two. So maybe it would have been nice if I did this. with the exact same signature. Bless you. That was the quietest sneezing I've ever heard in my life. But anyways, so I'll put this one over here, right? So one allocates and copies, and the other one reallocates. Now I can actually choose which one I want to use based on my needs. Okay? So now I'm going to come over here in my name. In here, I'm going to say, okay, this is just an allocation and copying, right? So I'm going to say ut.allocopy. Wait a minute. Yes. Sorry, I was just thinking of something. All right, so in here, I'm going to say put in m value the value, right? Allocate and copy. And here it's going to be, if that's the case, ut.allocopy into m value the value, right? And in here is reallocate and, pardon me? Oh, yes. So this is reallocate and copy. Reallocate and copy into m value n dot m value, right? Do we have it anywhere else? I don't think so, right? Now the code is better. And now I can actually write stuff in here that makes sense and not to babble. You know what I mean? So if last one is not, then I'm going to say ut.allocopy into m last name, the last name. Otherwise, m last name, no last name.
Is there any reason why you prefer to the utils as a class, as an object instead of?
Yeah, I'm writing an object-oriented language. Why do I go structured backwards?
No, because
in OOP244, you're going to learn that we can actually make that a real utility class. So you can have member functions in a class that are just functions that you can use. They're called static functions. So instead of creating allocopy like that, I can make, you'll learn in OOP244, okay? In OOP244, you'll learn how to create static functions, and like that, your utility is going to be complete. You don't need to instantiate your utility anymore because their functions are static, and usually utility functions are static functions. You'll see it soon, but not now. Yes. 2 points, 2 points. It means classes method. These are not class methods. These are object methods. Class methods are methods that exist no matter if the object exists or not. Those methods are called static methods, OOP244. Static methods are done with scope resolution, 2 columns, which means no matter the functions exist even if the objects don't. The functions belong to class. The functions that gets created when the object is created are non-static objects. That's why it's dot. Okay? We don't know how to create static functions yet. That's why I'm using this version, OOP244. You do the scope resolution thingy. Okay? So I think we're done with our full name, if I'm correct. Now let's go to the copy constructor. Now I want your attention over here. So when you are creating the copy constructor, you are responsible to remember that how you're supposed to use your parent's constructor. Remember that any child can be referred to or pointed to by the parent's name, right? Correct? So freely you can say over here name, and you pass fn over here. I know you are telling name to copy full name. Well, because it's being referred to as fn, when it goes into the copy constructor of name, it only copies the name part of it. So you can pass the reference of the parent directly to name. Okay? There is nothing wrong to do so. And then in here, I'll do the rest. So in here, I'm going to in here, I'm going to say operator equal and fn. But if I do that, then there is something redundant happening in here. Because my full name is going to copy the whole full name, I didn't need this one anymore. Again, see how you are. That's why classes with resources are so fragile. And there are things. So either I could do this, which means name will be defaulted first and then overwritten by assignment operator, which sucks. A dynamic memory allocation will happen. So this would have worked, which means, again, name is defaulted, and overwritten. And overwritten exactly, written by operator equal. Okay? That's that. Or I could have done this. So I call the constructor, and I do not use the operator equal, but manually do the copying of the parent part. This is more efficient. The other one, a dynamic allocation happens with no name in it, and then it's deleted and reset. In this one, it's not. So in this one, now I can actually write something like if. I don't even have an if. I just simply copy. So in here, I'm going to say ut.allo copy, because it's a new one. I can say m last name and first name dot m dot last name. Do I need to check to see if last name is null? Fn's last name is null? No, it's impossible. We know that the last name is always set to something. We designed it in a way that it doesn't have a safe state. It is always safe. The object cannot get created with null, so this is always there. And in your allo copy, we can actually do that, even make it safer. So in our allo copy in here, I can actually check and say if source do this, and then do else something. So you can do that in your allo copies. Make your allo copy more intelligent. Okay? But again, allo copy is allocating and copying, is not setting anything to null. So I'm not going to do that, not to have what we call hidden logic. Okay? The function allocation and copying says this function is allocating and copying. It doesn't say if null, if source is null, it's going to do this and that. Yes? Oh my God, yes. We have to go through humongous amount of logic to test for safe states. I didn't create a safe state to focus on classes, derived classes with resources. Okay? We can later on change that one and put a safe state in it and see how much logic I have to add to every single time, check and see if I'm in the safe state, do this or not. Okay? We'll change that later to that one if we have time. So I'll add the safe state if we have time. So this allocate and copy, like you could do this. You can say else over here, destination is null PTR, right? Or set the destination to null PTR anyway and then do this, not to have two things over here. And for the this one for reallocate and copy, yeah, this is good. There's no need because this is going to set it to null anyway. So I'll delete it. Then I'll call this one delete it, and I'll set it to null. So there we go. So now if source is null, it's going to make the destination null too. Okay? But it's never going to happen for us. So my alloc copy is safe, but it's never going to happen in here. I don't need to care about it. Okay? So that's that one. I could have done this one, but again, this is inefficient. This is more efficient. Don't blindly do something. And it's just a function called to the way I created it. So nothing extra is happening in here. And then the destructor for it, full name, is just deleting last name. Do I need to worry about the first part? No, I don't, because why is it not seeing the last? Oh, because I have to say it belongs to them. I don't need to do that because I made the destructor virtual, so everything will be deleted. So I'm fine over there. Just making it virtual is fine. But now we're going to go to operator equal. So how do we do operator equal in here? So to do operator equal, the very first thing I need to do is to set the parent to whatever it is. So again, I'll go through the same thing. If this is not equal to address of fn, and then I'm going to say return this, right? And then what am I going to do over here? I'm going to say operator. I'm going to say name operator equal fn, which means pass the parent to the operator equal of name. Therefore, name will do the copying for the name, and I'll do the rest over here, which is ut.reallocopy into m last name, the first name's m last name. And I'm done. You follow what happened? You follow what happened? You have to delete it. If you didn't have anything, yes, you could. Yeah, I have to delete the last name. That's deleting the name. Last name is I'm taking it. And now I have, oh, I didn't do the right. Did I? No, I didn't do the right. So for writing how I do it, that's simple. We know it. You've done this with virtual, so there is no tricks over there. All I need to do over here is to say return name, right. Do you see what's the difference between scope resolution and dot here? Right belongs to the class. Okay. So in here I pass the OSTR, and then I'm going to pass the probably a space, and I'm going to pass the m last name, right? And I'm done. So it prints the first name and last name now. Okay, so what is the whole purpose of all this lecture that we had today? When you have classes with resources, you have to be careful what happens to the parent if the parent has resources and it has rule of 3. When you are doing operator equal, the quick way out is to write assignment operator. Then there is no need to do that because assignment operator is doing all the copying. So as you see, assignment operator is already setting the name. So you don't need to worry about that. The only problem with that is that when you do that, because it's a function call, as I told you, when we get into the body of the constructor, everything is already initialized, correct? Therefore, your parent's name will be no name first, and then that is deleted and reallocated to the value. You have one extra dynamic memory allocation happening if you go with line 16 to 18. which means your code will be slower than mine. Mine has 2, yours has 3. And dynamic memory allocation is very, very expensive process. What is expensive in computer programming? Time. Time. Because it has to make a request to the operating system. Operating system must see where we have memory, allocate, set lots of stuff, give it. So it's not an easy thing to do. It's slower. Okay, dynamic memory allocation is always slower, and we have 4 minutes to spare. 45 it ends. 45. We have 1 minute late. So thank you. Have a beautiful day. I'll see you the next day. Okay, I'm just going to pack things quickly. If you have a question after the class, don't talk to me. I easily get distracted.